Hello guys, this is our online e-learning platform we recently launched for those aspirants who want to crack J and NEET examination uh, in at very lower cost. This course is designed especially for those students who are not able to afford this high, fees. This is the name and fame of the institute, and most of the students on the name of students rush behind them, but last what happens, the money is lost and nothing happens. So we came here for in at very cheaper cost. We are providing a quality full content for JEE and NEET examination and other state level engineering and medical examination. So this is the guys our online e-learning platform value Edupoint. Okay, here in even in even in 150 rupees, okay, in 150 rupees per month you can start your preparation for JEE and NEET. Okay guys, even in 150 rupees, or our course only for just in 1500 plus some charges. Okay, we are taking I assure you, I challenging you guys, nobody is providing you at this cost and such qualityful content. Okay, quality content. So if you want to prepare, if you complete your dream, if you want to make your foundation firm, so you can start your preparation since ninth standards. Okay, since ninth standard start, purchase, explore our courses, our value as you point, go to our visit our site and purchase which course you suitable, whether NEET and JEE and other courses are available for just like SC Pharma series, IE Rodo, NCRT Exemplar, and any so many courses are available on this our platform. So you can purchase what suit you. Okay guys, so we are starting our SC Verma series. Okay, part 1. Today we are starting exercise first of kinematics chapter. Okay, so guys, we will start the first question. So this is the very easy problems. First of all, whenever you start problem solving, so you should read question 1 to 3 times, at least 3 times. Okay, in 15 to 20 seconds. Okay, then focus on the given data. Okay, the keywords, and then try to find out the exact answer related to this data. So now we will starting our first question. Whenever you see these type of problems, I always suggest you to prefer the direction diagram. Okay, when you use this direction diagram, so that will be easy for you to deal these problems. Is it okay guys? So you are familiar this diagram? Okay, this is called nudge. Okay, east, west, south. So you already studies in your, sorry, this is not north, this is east. This is the direction of east, this is the west, this is the north, this is the south. Is it okay guys? I think okay, this will be helpful for you. Now what we have to do, the question is saying a man start from house. Okay, from here to, suppose that the origin its house. Okay, he walk in north direction, or we can assume the direction is 50. Sorry, not assume, it is given 50 meter in north. Okay, now again he moves in east, that is 40. Okay, that is 40. Sorry, that is 40 guys. Or again towards the south he comes 20 meter. Okay, this is the guys. Okay, 20 meter. Is it okay guys? Is it okay? So this is the house of that person, and this is the field. Okay, this is the field. Is it okay guys? This is the field. This is the field guys. So now what we have to do, the question number first he is asking, that is what distance he has to walk reach the field. So whenever he ask distance, then what is the distance? Remember guys, nobody will tell you what is the meaning of distance. So the distance is the traversed path length. Traverse path length. Okay. The actual traverse path length means how much kilometer he ran. So you can see he traversed 50, 40, 20. So directly the distance is 50, 50 plus 40 plus 20. When you solve this, then 110 meter. This is the distance traveled by that man. Now we are talking the dis. Now guys, for the part B, what we have to do, we have find out the displacement. Okay. And what is the displacement? Displacement is the shortest distance. Okay. Shortest distance between final position to initial position. Is it okay, guys? Is it okay, guys? So this is the displacement. Now you can see visually very here the displacement is this. Okay, the man displays from house to field. This is the displacement. Okay, we can give the another color of this. So this is the displacement, guys. Okay, this is the displacement. We can numbering this. This is the O, this is the A, this is the B, this is the C. Now we have to calculate this distance. We make a triangle. Okay, this is a triangle, or I can take this point is D. Okay, guys. So CD will be equals to 40 because this is the parallel same vector here, and this distance will be 50 minus 20. That will be 30. Okay, so the OC distance in triangle OCD. So the OC is equals to, from Pythagoras theorem, that will be 30 square plus 40 square, and that will comes out to be 50 meter. Is it okay, guys? Now we have to give the direction. Okay, so for the direction always that is slope or tan theta. So this is the theta, again this is the theta. So in triangle we can calculate tan theta. Tan theta will be equals to 30 by 40, and that will comes out to be 3 by 4. Okay, and theta is equals to tan inverse 3 by 4, or we can say 37 degree from east. Is it okay, guys? So this is the very easy problems. Okay, so remember these two concepts always: distance, traverse path length, and displacement, the shortest distance between final position to initial position. Again, to solve these problems, we make okay, Cartesian axis. This is the okay, we can take this is the origin point. Now what question is saying, from this point a particle moves in this direction. Okay, up to a point, point that is 20 0. Again the particle start to back return. Okay, or he moves up to this point. Okay, up to this point, and that is equals to, that point is equals to minus 20 comma 0. Now what we have to do, in first part we have to calculate the distance again. So distance again, the actual traversed path length, and that is first you go in 20 and plus, again he will return in this direction, negative, in opposite direction. So he will move 20 plus 20, that will be 40, so 60 meter. So the distance traveled by the particle is 60 meter. But when we talk about displacement, so displacement always that is change in position. Here position vector is x-axis, so we can say x final minus x initial. When you put x final, that is minus 20, and initial, the particle initially start from 0, so the coordinate is 0, so minus 20. Okay, that is displacement. or we can say 20-meter direction negative x-axis. Both answer are right. Now we will go the next question. Again we will okay, again this is the good question, guys. Okay, so what question is saying, this is the two places here. Okay, this is the Patna, this is the Ranchi. Okay, so by air, if you go air, the distance between these two places, that is 260 km. Okay, or when you go by road, the distance is more. Okay, and that is comes out to be 360 320 km. This is the road. And additional data is given when you go aeroplane. When you go through aeroplane, the speed, the time taken by aeroplane, that is 30 minutes, and by bus 8 hours. So now the first part is the average speed of plane. Average speed of plane. So whenever you find average speed, then total distance upon total time. Remember, guys, this formula: total distance upon total time, and that will comes out to be the total distance from by air, that is 260 km, and the time taken by the aeroplane, that is 30 minutes. When you convert this hours, then will comes out to be 520. Okay, and the part B, the average speed of bus. So now in this case, what will you do? This is the 320 km, the total distance, and the time taken, that is 8. So this will comes out to be 40 km/h. Now the problem number C, the average velocity. Okay, the average velocity of plane. So that is, guys, always delta x, total displacement upon total time, and the distance between these two places, the shortest distance, that is 260. Okay, time again 30 minutes. Okay, when you multiply this, 520 km/h speed will come. Sorry, velocity will come. Now the last part, that is very important. Okay, most of the guys will do this wrong. Okay, so the average velocity, okay, the average velocity of bus. Now, guys, again the total displacement of total time, but we earlier discussed that displacement is the shortest distance. Okay, displacement is the shortest distance. So in between these two values, the shortest distance, that is 260 km. Okay, and the time taken by this, that is 8 hours. So that will comes out to be 32 32.5 kilometer per. Okay, guys. So the last part is very important of this question. Is it okay till now? Okay, now we come the question number fourth. Okay. Okay, there is a speedometer. Okay, the reading is the final reading. The final reading 12416, and the initial reading is given 12352. Okay, when you subtract this will comes out to be 64 kilometer. Okay, the whole journey. Okay, the whole journey is 64 kilometer. Now what is asking, number first question, the distance traveled, the average speed. Okay, what is asking, the average speed. Okay, so average speed, that will be equals to total distance upon total time, that will be 64 kilometer. Okay, the total distance upon total time, that will comes out to be 64 upon The time taken is 2 hours, so that is 32 kilometer per hour. But in next question he is asking guys average velocity. So when velocity will comes into picture, then distance will become displacement. So total displacement upon total time. Okay, so the displacement guys, one person start from his home. Okay, he goes in this direction. Okay, he planned his journey, he moves in this path, and again he comes at home. So the total displacement is 0. Okay, time taken 2 hours, the velocity will be 0 kilometer. So why average velocity is 0? Because the total displacement here is 0. This is very important. Here displacement is 0. Why? Because x final minus x initial. There is no changes in position. That's why displacement is 0, guys. Okay. So now again so for next problem, the question number 5th. Okay, guys, it is very easy when you start solving. Very easy problems, guys. You will not face any difficulties. Okay, this is the very easy question. Time is given. The maximum speed is 18 km. What is the magnitude of his average acceleration? Now, if you are able to, okay, understand problems, and if you are perfect, you can convert these problems into graphical. So that is very good for you guys. Okay, so what he is saying, the question is saying, one athlete takes 2 seconds to reach his maximum speed. Okay, so particle is going in this direction. So this athlete going, its velocity is increasing. Okay, this is the velocity, this is the time. So he is saying he starts from 0 into 2 seconds. Okay, what is the value of this particular time? That is, what is the value of this particular time, guys? That is 2 seconds. Okay, this is t equals to 2 seconds, and the velocity of at that point, the maximum velocity of at that point, okay, and that is 18 kilometer per hour. This point, guys, this is the V max. Now he is asking the magnitude of average action. We know the VT curve, slope of VT curve will gives the VT curve is equals to acceleration. Okay, guys, so we can calculate acceleration will be equals to tan theta. Okay, and tan theta is equals to V max upon T. That is, okay, here 18 kilo. Remember, guys, you have to convert unit. Okay, and here time is 2 seconds. Now we have to convert this velocity into meter per second. So directly multiply 5 by 18. Okay, so this will comes out to be 2.5 meter per second square. So very easy, guys. Okay, so now for the next problem, question number 6. Okay, it is very simple problem. Now again, is VT curve, speed time curve is given. He is asking find the distance traveled by the car in 8 seconds and its acceleration. We know the distance is area under speed time curve. Area under speed time curve or VT curve. Speed time curve and, guys, VT curve. Okay, so for distance, what we have to calculate, this is the part A. The area, okay, you can see the area, this is the straight line, the area under the curve will be triangular portion. Okay, guys, this is the triangular portion. Now see, guys, so the area of triangle, that is half, and base is equals to 8, and the height will be equals to 20. When you solve this, the distance will comes out to be 80 meter. So now guys, till now there is no problem. Like, okay. Now for the acceleration, okay. For the acceleration, what we have to do, the we earlier in last previous question we have discussed acceleration is the slope of VT curve. Okay, this is the slope of this line. Okay, that is tan theta, and that will comes out to be the height, that is 20, and the base is at, when you solve this, the value will comes out 2.5 meter per second square. Okay guys, if you are able to, okay, if you are able to, okay, make connection between, make a relation between these values, so there is no problem. Otherwise you will face difficulties. Okay guys, so now the next problem is seventh question, and that is a very good question. Okay guys, very good question. Okay, that mark important question, that is very important question. Okay, very good question guys. So now to solve this problem in very easy way, what will we do, we will convert this diagram, this is 80 diagram. Okay, this is the acceleration, this is the time on x-axis, we will convert to into VT diagram. So what is VT diagram? Velocity into time curve. So guys, what is happening here in this particular journey? So now guys, what we have to do in this question, we have already given the 80 curve. Okay, so now we will talk about the curve. Okay, we make this curve into VT curve. Okay, we'll make this to VT curve guys. Okay guys, see what is happening. Okay, first the body will start, the acceleration is 5 meter per second square. The body will start from t is equals to 0. He achieve an maximum velocity. Okay, then after acceleration 0, it means the velocity will be constant. Okay, because, okay, t equals to 20 seconds, the velocity is constant. Now what we have to do again, then retardation and the velocity, the particles, the cart will comes out to, will come into rest. Is it okay guys? Now what is happening here, so you can see timing here. Okay, you can see timing here. So when you solve in this method, that will be very easy for you. Otherwise in theoretical matter it will take time and you will not understand. That is the part 1, that is a part 2, that is part 3. Is it okay guys? Okay, this is the part 3. So now this is the OA point, this O, this is the A, this is the B, this is the C. Okay guys, so here the velocity will be the maximum velocity achieved. We can calculate. Okay, why? Because that particle start from 0. Okay, 0. So here this point we can calculate the velocity is equals to u plus at. Okay, initial velocity is 0, then acceleration is 5 and time taken is 10. So maximum velocity comes out to be 50 meter per second, and this is the time, this is the 10 second, this is the 20 second, or this is the time 30 seconds. So is it okay guys? Now the first question is asking the distance. So we know the distance is area under the VT curve. Okay, area under VT curve. Is it okay guys? So when you solve this, so the first part area, that is triangle, we know the base and height. Base is 10, height is 50. Okay, and in distance we always take the area modulus. Okay, we will discuss later on in next question. And the second area, that is rectangular. Okay, that is the 50 is width and 50 is height and the width is 10. Okay, and the again next area is, okay, that is also triangular. When you solve this guys, that will comes out to be 5, this half 500 plus this is 500. and that will comes out to be 1000 meter. Is it okay, guys? Now for the second case of this problems, now we have to draw the position time graph. Okay, so t equals to 0, the position will be 0, and t equals to 10 second, we know the position, the area of this. See guys, okay, the area under this vt curve will gives the displacement, okay, or position. So t equals to 10 second, the area of this, that is 250. Okay, when you solve this part you will get 250. Okay, so the area of this, that is 250. Is it okay? And the area of again this is also 250, and the area of this, that is 50. So we can easily draw the curve. Okay, so now guys, for the second part of this problems, what we have to do, okay, for the second part of this problem. Okay, see guys, look at this. Okay, look at this diagram. So we make the graph between position and time. Okay, sorry guys, we make the graph between the position and time curve. This is the timeline, this is the time axis, and this is the, okay, sorry guys. So okay, so now look at this guys, from point 0, this from origin, the distance will be equals to 0, and at t second, okay, this is the time axis. Okay, this is the time, or this is position. Is it okay guys? This is the position axis. Okay, or we can say x axis, or we can say s. Position is denoted as s, or this is the time t. Okay, this is the value of time t, 10, 20 and 30. So carefully guys, at 10 second, the area under the curve will be 250. So here this value comes out to be 250. And at 20 second, the area, okay, now the curve is, now the body, the traverse from this up to this, the area under the this whole curve, and that will be, okay, for your assumption I am telling you, the area under the whole curve up to 20 second, that will comes out to be 250 plus 500. Okay, that will comes out to be 750. Okay, is it okay? And at 30 seconds, the area under the hole, or we can already calculate, that is 1000. Okay, and when you join these points, you will get a straight line. Okay guys, this is the our position time curve. Is it okay guys? Now for next problems, that is problem number 8. So in 8th, what we have to do, the again vt curve is given. Now the acceleration and the distance travel in 0 to 10 second, and the displacement is 0 to 10 second. Again, this is the very easy question guys. Okay, see, we make triangle to calculate slope. Okay guys, when you take this, okay, this is the value theta. Okay, the first question is acceleration. We know the acceleration is tan theta, or slope vt curve, and that is equals to, okay, this is the height. Okay, this is the height, and that will equals to 8 minus 2, and the base, that will comes out to be 10. So this will comes out to be 0.6 meter square. Is it okay guys? Is it okay? Now for the b, again we have to calculate b part. So we will okay, this area under this curve. Okay, this is the area under this curve. Okay guys, this is the, and this is the part area 1, this is the area 2. So distance is area a1 plus area A2. Okay, and area A1 we know the half, triangle half, base is 10 and the height is 6, plus the base, second part of second area is rectangular, the base is 10, width is 10 and the height is 2. When you solve this, guys, that will comes out to be 50 meter. Okay, that will comes out to be 50 meter. And for part C, guys, that is displacement. Okay, guys, so the displacement, again the area under this curve, so displacement again will be same, that will be 50. Now guys, we are starting the question, next question, that is question number 11. Okay guys, so in question number 11 he is asking, what he is asking, in xt curve, okay, of a particle. Find the time t such that the average velocity of particles during the 0 to 10 second is 0. So what is the average velocity? Again, I have earlier in question I have discussed so many times, average velocity is total displacement upon total time. Okay guys, or we can say delta x bar upon delta t, or we can say, or this is delta r. Okay, change in position upon changes time interval. So that is changes position, that is here is x, so x final minus x initial, and time delta t, this is average velocity. So for to be 0, time cannot be 0, so this displacement will be 0. So for average velocity to be 0, it implies that x final minus x initial. It means the initial and final position will be 0. So you can see guys here, this is the initial position or this is the final position. Okay, okay, so at this point you can see the displacement is same, so the time taken will be, if you draw downwards, okay, so the time is given, time is taken, that is approximate 12 second. So, okay, so at t equals to 12 second, the velocity will be, average velocity will be 0. Okay, from 0 to 12 seconds, the average velocity will be 0. Remember guys, that is very important. So now guys, we are going to next problem, that is question number 12. Again, this is very easy problem, you can crack some concept. Okay, he is asking, a particle starts from a point A and travels along the solid curve shown in figure. Okay, in this figure, this is the particle path or curve. Find approximate position of position B of particles such that the average velocity of position between A to and B and the same as the direction as instantaneous velocity. So guys, look at this, what is the concept of this phenomena? What is the concept of this phenomena, guys? Okay, look at this. If we are talking about, okay, suppose that this is the curve, if we are talking about this is the point A, this is the point B, if we are talking about the average velocity, the average velocity in this direction, okay, A, this is B, so V average equals to in this direction. Okay, or if we talk about the instantaneous velocity, suppose that this is the point C, this is the point C. If we talk about instantaneous velocity, that will be the tangent up to at this point. Okay, this is the velocity of c. So in this case, the velocity vc parallel to average velocity vb. Okay, this is the parallel, means direction is same, magnitude may different. But if direction and magnitude same, then the instantaneous velocity at c and the average velocity ab will be same. Okay, so similarly in this case, so when you guys look at this point very carefully, okay, I'm drawing a dash line. Look at this point. Okay guys, look at this point. And again, if I join this, look at this point, you can easily, when you join this to this, okay, this is the point b, is the point a, this is the average velocity. Okay, a average velocity, this is the direction of average velocity. And again, the direction of instantaneous velocity at the point b, that is also, okay, to understand you, I change the color this. Okay, so the this is the green color, that is instantaneous velocity at b. So at this point, the both velocity will be equal. So the coordinate of this point, that is 5, and this is 3. So the point b coordinate, the x coordinates will be 5 meter and the y coordinates will be 3 meter. So this is the concept you have to remember in your mind. Okay, now the question number, very easy question, question number 13 question. Okay, question number 13 is very easy guys. What question is saying, a object having a velocity 4 meter per second is accelerated at a rate of 1.2 meter per second for 5. Find the distance traveled during the period of acceleration. Very easy question. Distance simply s is equals to ut plus half a t square. Okay, and ut is equals to 4, time is 5 second plus half, the acceleration is 1.2, time is 25, when you square 5. Okay, when you solve 20, and this will comes out to be 15, sorry 9, 15, and that is 35 meter. So now this is the question number 13. Now we will discuss about the question number 14 guys. Look at this very carefully. This is the a person is traveling from this speed, applies the brake, and deceleration 6 meter per second square to his scooter. How far will it travel before stopping? So what's going on here? Before the apply of brake, how far will it travel? Okay, so very easy. S is equals to ut minus plus half at square. Okay, the initial velocity already given. We can convert 43.2 if I multiply 5 by 18. Okay, in meter per second. Is it okay guys? That will be comes out to be 216. Okay, or if we take 9, 12 meter per second. Okay guys, so now 12, time is not given, so we have to first calculate time, and minus half, the acceleration is given, and acceleration deceleration, that is 6, and again we have to calculate time. So for stopping, the final velocity is equals to u minus 6 into t. Okay, this final velocity is 0 at stopping, and that is 12. So t will comes out to be 2 second. Okay, when you put this value here, when you solve this 20 minus, okay guys, when you solve this will comes out to be 12 meter. Okay, hello guys, this is the last today's in this lecture. This is the last problem of 15. Okay, a train starts from rest, moves with a constant acceleration 20 meter per second for a half minutes. Okay, then brakes are applied, then the train comes to be roast in a 1 minute. Okay, so now so the first question is the total distance moved by the train. So one by one we'll discuss this problem in first. So what is happening? See guys, if I draw VT curve, that is very helpful. Train from rest and from 2 meter per second squared, train moves in this direction. Okay, so half minute. Okay, this will comes to this point will comes to be this point will comes to be, okay, this is the half minute, or we can say 30 seconds. Okay, we can say 30 seconds. Again he run for 60 seconds. So this t will be equals to 90 second. Is it okay guys? This will comes to be 90 seconds. This is the t equals 30 seconds. Here the acceleration is 2 meter per second square, and here deceleration we don't know, we have to calculate. So at this point we can directly, the maximum velocity will be 2 into 10, that is 30, is equals to 60 meter per second square. Or we can directly calculate v is equals to u plus at. Here u is 0 from starting rest, and the is this point. The final velocity at t simply, that is, this is the acceleration, this is the time, 60 meter per second. And now we have to calculate deceleration. Yes, final velocity is 0. So again you calculate, that is v is equals to u minus at, that is 0. Okay, we know the initial velocity is 60. So the x deceleration will comes out to be over here, that is minus 60 divided by the time interval is here 60 minus 30. Okay, sorry, this is the 90 minus 30, that is 60, which will comes out to be minus 1 meter per second square. So this is the part 1, this is the part 2, the distance traveled by, total distance moved by the train. So we know the distance will be area under the curve. Okay, and the magnitude we will take distance, area under the VT curve, under the area, sorry, area under the VT curve. Okay guys, area under the VT curve. Is it okay? So now the first portion, the part 1, that is equals to half, the base is 30 and the height is 60, plus half, the base is 60 and the height is 60. When you solve this, okay, this will comes out to be, sorry, 15. Okay, this is the 15, and that is comes out to be 900 plus, that is comes out to be 1800. When you solve this will comes out to be 2700 meter. Okay, this is the answer of first question. Now The second question, the maximum speed attained by the train, we have already calculated. Okay, P max, that is equals to 60 meter per second. Guys, when you approach this question with the help of diagram, the plot vt, at, xt, if you have a depth knowledge, so the maximum velocity, that is vmax, is equals to 60 meter per second. We have already calculated here. Now the part C part is the positions of the train at half of the maximum speed. So guys, look at this in visualization. This is the maximum speed. Okay, so at this position, this is the maximum speed, that is 60, or this is the half, that is 30. So at this position and this position, okay, velocity is same. So we have to find out the positions of this particular moment at this particular moments. Okay, so now we have to find out the positions, that is part C. So first we find out the x1 position. Okay, x1. So here we can directly find out x is equals to half at square, acceleration is 2, time is, so now we have to calculate which time, we don't know, so no problem, we use another formula. Okay, we use another formula, that is third equation, that is v square is equals to u square minus 2ax. The initial velocity is 0, sorry, plus 2as. Okay, we know the v, the value is 30, that is square plus 2 acceleration, that is equals to 2, and the position x1, or we can say the more appropriate s1. Okay, rather than x1 we use s1. Okay, so s1, this is the s1. So s1 comes out to be 900 divided by 4. Okay, if 925, and that is equals to 225 meter. This is the first position where the velocity is half of the maximum. At velocity will be 30. Is it okay, guys? Now the part second of this problem. For next position, what we have to do, first he will cover this distance. Okay, and that distance we have already calculated. See, we have already calculated in this portion. Okay, this is 900, guys. This is the 900. Is it okay? So for s2, first he cover, for s2, first he cover the 900 distance plus up to this journey. Now he will cover up to, from here the velocity 60 to 30 in this related portion. So now we have to calculate the area. Okay, distance, that is, we can say that is s, and we can easily calculate s is equals to v square minus u square upon 2a. V square, that is 60 minus 30, and here a will be equals to 1. Deceleration. Is it okay, guys? Is it okay? So that will comes out to be 60 plus 30, or 60 minus 30. It is very easy way to solve this type of problems. Okay, or when you solve this 90 and 30 divided by 2, that will comes out to be, okay, that will comes out to be 13500. Okay, so the next position, when you add this 900 plus 1350, okay, so this will comes out to be 2250 meter. Okay, guys, this is the first position, this is the s2 second position, where the velocity will be the half of the maximum velocity. So this is the our lecture number first of exercise first of kinematics. Okay, guys. So you can start your preparation for JEE and NEET. You can purchase our app JEE, NEET, BEDSET, 11, 12, whatever you require. You can start your preparation since ninth standards. Okay, since ninth, 10th. Free foundation. Okay, and you can download our app from iStore on Google Play Store. Okay, guys, and you can visit for more information our website www.valueedupoint.com. Okay, you will find here so many courses of which is designed by me for JEE and NEET experience, and it is very cheap. It is very cheaper cost. Okay, it is at a very cheaper cost, guys. You can start, you can spread this, you can explore our platform, guys. Thank you so